Good morning. Let us get started with this chapter 17, which is on project management. We'll look into different aspects of what a project is, what are the different management tools and techniques which are used to keep the project on track. We'll also take a look into the different risk aspects in project management and ways we can avoid some of those risks. So let's get started with this chapter on project management. The different learning objectives of this chapter, as shown here, we will look into the behavioral aspects of a project. It has both personnel and machines and material which are being employed in making a project successful. So there has to be a coordination between these different aspects of the project so that things are in place and run smoothly. The techniques like PERT and CPM, which are being used to map a project and to make sure that it is on time and the resources are allocated properly. We'll also take a look into deterministic time and probabilistic time, and what are the ways in which it can be crashed. There's a term called project crashing. Now, what is project crashing and how it can be used to shorten the time span of a project? So these are some of the aspects which we are going to look into this chapter on project management. Now, the first question is, what is a project? So it is an one-time operations which is designed to accomplish a specific set of objectives within a time frame. So a project, it is a one-time operation. It is not a continuous or a perpetual operation. It is a one-time operation. So that's the difference between a project and production. Next, it has a specific objective. So we set the objectives before we start the project, and it has a limited time frame. It is not perpetual, it has a time frame. So a Olympic game, it can be treated as a project. It has a start date, it has an end date, and you have number of activities in between. Producing a movie can also be a project, a software development. So nowadays this is really important. Software development and implementation, that's a project. Not when the software is applied in an organization. So that's perpetual. So it goes on and on being in operation, but that's not a project. Project is the development of that software. Product development, ERP implementation. Again, ERP is a piece of software which is available over the shelf, and it is implemented, it is customized based on the customer's requirement. So that's again a project. Every project has a life cycle. So first we set up the goals of the project, the specifications, the feasibilities, what are the different responsibilities, and so on. So that's the first phase when we define the project. Next, we go into the planning phase. How much time, budget, resources, what are the different skill sets which are required? What are the personnels who can be deployed in the project? So that is project planning. Next, we move on to the execution. When the project is actually executed, the software development or the building construction takes place. So that's the execution phase. And from there, after the building is being constructed, after the construction phase is over, it is delivered to the people or the owner. Okay, so there is a specific delivery phase. There is some paperwork required for that handover of the project. For software, there is some training which is required for the customers. There's some documentation which are needed to be transferred. So that's the delivery phase. So this is a typical project life cycle: the definition, planning, execution, and delivery. So the project goes to nature of projects. The project goes through a series of life cycle. Projects bring together people with different or diverse knowledge and skill. We need people with different skills in a project. Like making a building might require people with experience of artwork, with experience of design, construction, uh, painting, electrical, mechanical, and whatnot. So people have got different skills who come together to make that project successful. Organizational structure affects how projects are managed. So it can be divided into silos, or it can be a horizontal structure or a vertical structure. So depending on the structure, the management of the project can be determined. A project manager is the person who is responsible for the success of the project. Um, he makes sure the right people are selected. He identifies and assigns responsibility to individuals. He understands, or he determines the time required for the project, the cost required, the resource allocation. So the project manager is ultimately responsible to make the project successful, and he's also responsible for the smooth running of the project. So at every phase, he has got a significant role to play. Behavioral issues. Now, the project has personnel with different skill sets. A project has personnel at different level of hierarchy. So there is a lot of behavioral issues which gets into that project. So when two people work, it's not only the work that they are delivering, but it is also involving the interpersonal relationship. Now, the next thing which is important is, in a project, whether all decisions are taken at a centralized location. Maybe it's just the project manager who decides everything, or is it decentralized? Is it taken care of by each individual project leads or team leads? In a project, there can be team leads. So does the team lead decide what is to be taken? So this structure determines to a big extent how a project is run. So that interpersonal skill, how people are being involved, how the problem between two personnel are being tackled, how the conflicts are being resolved. So those are different behavioral issues which is part of a project. So because there are different personnel, different skill sets, so there is bound to be some behavioral issues, and a project manager has to deal with that. Avoiding problems. Many problems can arise. It is first and foremost, the team should be selected properly. The leadership should be assigned in the right way. People should be motivated. Maintain an environment of integrity, trust, and professionalism. Being supportive of team effort. So these are again needed. These, we all know this. Like, these are good to make a project successful. But how these are implemented, how effectively people are being motivated, that's what makes a project success or a failure. Project champion, sometimes it may not be the official hierarchy, but there are people who um, voluntarily take up responsibilities, voluntarily take up leadership role, so they become inspiration for the rest. So a person who promotes and supports a project usually resides within an organization, facilitates the work of the project by taking up the project to other managers, and he might ask to share resources with the project team and so on. So it is important that project manager identifies these project champions so that they can be inspired and they are motivated, and they in turn can motivate their team members. Now it can again, when I say team member, that may not be an official team, that is people who work with them, his colleagues, um, people all around him, so they can be motivated by these project champions. Now we get started with different aspects of a project. The first and most important is WBS, work breakdown structure. Projects are typically broken down into smaller structures. So it can be broken down into, say, two structure, which can be subdivided into three more, and this can go on. So it can go to different level of division. The more fragmented they are, or more we break it down into smaller substructures, we try to look into finer details. So from macro level perspective, we move into micro level perspective. So that is work breakdown structure. Now over here we see that the project, which is in level 1, it is broken down into three structures or three smaller tasks in level 2. In level 3, it is broken down into 8 tasks, which is broken down into, say, 11 tasks in level 3 or in level 4. So this goes on. We can go even further down, but it is advisable to restrict it maybe to level 4 or level 5, because if you go beyond, it becomes little complicated. The interaction between those tasks become complicated, and it is sometimes becomes unnecessary to break it down to even further subtask. Now Gantt chart is a tool which is being used to represent the project activities in a bar chart format. So length of each of those bars is the duration of that specific activity. Say over here, locate new project. It starts at day 0. It continues up to week 8. Okay, so that's the span of that that's the time duration of that activity. If you take the third activity, hire and train staff, that starts on the 4th week and continues till 13th week. So it not only shows the duration of the activity, but it also shows the start date and the end date of that activity. PART and CPM is a little advanced tool compared to the Gantt chart to represent a project. So it is a graphical display of the project activities. It estimates how long a project will take to be completed. It identifies activities which are critical. We call it critical because if those activities are delayed, the whole project would be delayed. And indication of how long the activity can be delayed without delaying the project. So some activities cannot be delayed at all. Those are the critical activities. The non-critical activities can be delayed, but there is again a limitation of how much you can delay them so that the whole project is not delayed. Network diagram. In this PART and CPM technique, we represent the project in a network diagram. In a network diagram, we can represent an activity on the arrow, activity A. So the activity is represented on the arrow, or it can be represented on a node as well. So this node is activity A, and we have another activity B, and they are linked with one another. So activity B can be started only after activity A is completed. So again, these are two conventions of network diagram. One is the activity on, so this is an activity, this A is an activity here, and it is represented on that arrow. Don't get confused with this circle around A. So this A is actually on that arrow, but in the next diagram here, these activities are on the nodes and they're linked with arrows. Again, these are two different conventions. You can choose any of them. They will produce the same result. Deterministic time estimates. The time of an activity can be deterministic when we can say for certain that it is a specific time, say 5 days. So that is deterministic, or it can be probabilistic. We call an activity duration probabilistic when it can vary within a range, say from 3 days to 6 days. That is the time duration of that activity. So this is probabilistic because we don't know for certain how much it is exactly. We can give a limitation to the of the time duration of that activity, the mean time and the max time, and we can also associate or give it a probability of that happening. Then we have this concept of early start and early finish. So in a network, a network typically looks like this. This is a typical network of a project. Again, this is a very simplified network. Say we do activity on node. So these nodes are activities. Now if we estimate the start time moving from the origin, so we are moving, so say this activity A is 5 days, so activity B can start on end of the 5th day. So if we estimate the time moving from the origin forward, it is called the early start time. And if we calculate the finish of that activity, say B has got a duration of 4 days, so it will be over 5 plus 4. If we calculate the time by calculating it from the end day, drawing that network again. So it was A, B, C, D, E, and F. Say we calculate the project time and say we see that the project ends on the 22nd day. If duration of project F is 4 days, so the late finish of activity C would be 22 minus 4, which is equal to 18. And the late start of, if activity C has got a duration of 3 days, if this is 3 days, so that 18 minus 3, that's 15, would be the early start, would be the late start for activity C. So the late start of activity C would be 15, and the late finish of activity C would be 18. And this we are calculating from the end. We are moving backwards. Okay, so these are two ways of calculating time for activity: the early finish, the late finish, the early start, and the late start. Okay. Now, if we find the difference between the early start and the late start, we will get the slack. Slack can also be calculated by subtracting the late finish from the early finish. So slack is the time by which that activity can be delayed. So if you have a network, there are some activities which cannot be delayed. So those are called critical activities. So these critical activities have got zero slack. There are activities which can be delayed, and they have got certain slack. Now slack can be 3 days, 4 days, whatever. But the problem is, if you delay any activity by the total slack, that particular path that becomes critical as well, because you have used up all that slack. So what project managers do, they try to utilize that slack so that they can delay it by some time, but not the full time. So if the path has got a slack of 3 days, he might delay it by 2 days, so that even then he will have 1 day in hand. But if he delays it by 3 days, then that event becomes, or that path becomes critical. So by chance, if that path gets delayed by 1 day, 1 more day, then the project will be delayed. So project managers won't really want that. So using slack time, this is what I've been discussing. So project managers try to estimate the slack and see how they can make best use of that. They might divert the resources from the path which has got some slack to the critical path. In that way, the critical path can be shortened. If the critical path is shortened, the project would be over before time. So that is one advantage. But again, this allocation of resources or reallocation of resources should be done strategically and with great care, because if the whole slack is utilized, or if the resources are allocated to the critical path in such a way that the slack is used up, then what happens, that the second path which had a slack, that becomes critical as well. So then the project manager has to deal with two critical paths, which is risky, because if any of those paths are delayed, the whole project would be delayed. Now I had talked about the probabilistic time, where we don't know what the exact duration of the activity is, but we know the span within which it ranges. or the range of that particular activity, say from 4 days to 7 days. So now that 4 is the most optimistic time, so it's called TO, the optimistic time, and that 7 is the pessimistic time, which is the longest time, and we might have the most likely time, which is say 5. So we get 3, 5, and 7. So one is the optimistic, the other is pessimistic, other is the most likely time. Now, if we want to calculate the expected time, we'll use this model. It is the optimistic time plus 4 times the mean time or the most likely time and the pessimistic time. So if you divide that by 6, you are basically doing an weighted average of all those. You are giving more weightage to that the most likely time. So please understand that 4 is giving more weightage to that most likely time. And if we use this to calculate the time, it would be the expected time. That's what we expect from that activity, or that's what the time expectation of that activity. So if we take the time of all the activities in a path, if we sum that up, we'll get the path mean time. Now, by path we mean activities which are linked with one another from start to finish. When we talk about probabilistic time, obviously we'll get standard deviation, because the activities would deviate from the mean. So what we do in this case, we take two values, the pessimistic time and the optimistic time. We divide that by 6 and square it. That gives an estimation of the standard deviation. And if we add the standard deviation of all activities on the path, we will get the standard deviation of the path. Next, knowledge of path statistics. The knowledge of expected path time and the standard deviation will enable the manager to compute probabilistic estimate about project completion, such as the probability that the project will be completed by certain time, probability the project will take longer. So understanding the probability will help get a better understanding of when we are actually going to finish the project. So that is the path statistics. If you know about normal distribution, this is a typical bell curve which deals with normal distribution. And if you want to know what is the z-score of a specific time, so how much it deviates, the z-score tells how many standard deviation is any point on that curve. So you have a specific time, so this is a specific time, so mean is 4. So you want to know what is the z-score of that project duration, or the project of that activity duration being 6. Okay, so it would be 6 minus 4 divided by the standard deviation. So that was for an activity. If you take it for the project, so you can use the same technique. You calculate the project expected path time, and then if you want to find out what is the z-score of a specific time, you want the project to be calculated, then you can find the z-score. And once you get the z-score, you can know the probability associated. If you go to the probability table, that will give you the probability of this shaded region. Say it gives you a probability of 0.85 or 85% chance of the project being completed within a specific time limit. Project completion time. Project is not completed unless all the activities in that network is completed. if you consider, if a project manager only um, put all his attention on the critical path, then what will happen if you have one critical path and a number of other non-critical paths? Then what will happen is your non-critical path might become critical as well, which is a big challenge for a project manager. There are certain assumptions in this network which you are drawing. The activity times are independent. Each activity is only one path. So each activity is on only one path. That means this is what we don't do. So say there is an activity C, it will not be shared by two paths. We have different techniques of doing it. Um, we might include a dummy activity in between to represent the relationship between these different activities. Say this activity, say it is an activity F, which is to be completed before activity C is to be completed, and this is Z. So what we can do, we can say C and G, and you have an activity F. What we can do is we can introduce a dummy activity. So this here would be a dummy activity, just to separate an activity from two paths. We don't want this activity C to be shared by two paths. Then the processing becomes critical. We don't really want to into that. We don't want to get into that complexity. Simulation. When we consider probabilistic time, and when the activities we are when the activity time cannot be assumed to be independent, okay, so if one change the other will change. It's both probabilistic and it is dependent. So in that case, to solve the network mathematically becomes a big challenge. So in that case, we might use a simulation technique where this might vary. The time of this path can vary based on a specific range, and also this path can vary based on a range. Budget control is an important, again, all this time we had been talking about um, the project duration or the project time. But another very important aspect of a project is the budget associated with activity and the whole project as such. So the cost can be again, it can be a probabilistic budget where the optimistic time is taken to calculate the total project cost, or sometimes a lot of unforeseen events can be taken into consideration when we calculate the budget. Okay, so budget is more with the resource allocation, how much resource is allocated to each activity, and what variation do we assume in that resource allocation. Time cost trade-off. Activity time estimates are made for some given level of resources. It may be possible to reduce the duration of the project by injecting additional resources. Say a particular piece of work can be done by 5 workers. If you increase the number of workers, then what will happen? The project can be done at a shorter time frame. So instead of that 5 days, it can be done. So a project which requires 5 days and you have 5 workers. So 5 days and 5 worker. So instead of that 5, if I can have 8 workers, then maybe this can be done in 3 days. So this is the trade-off between the cost, the labor cost, and the time estimate for that activity. If I take all the activities, it would be for the project. Why do we sometimes add additional resources? So that there is we don't have to pay a penalty in delaying in the project being delayed, or maybe if you finish it early, there is a monetary incentive, the free resources for use on other projects. So you can use those workers in some other project or some other activity. Project crashing is when you allocate extra resources, um, extra labor, material, machine to make the project duration shorter. That technique is called project crashing. To make crashing to make decision regarding crashing requires the following information: the regular time and the crash time for each activity, the regular cost. So for every activity you require what is the regular time which is required, and what is the crash time, what is the regular cost, and what is the crash cost. List of activities that are both on the critical path. So list of activities that are on the critical path. What we do, we add additional resources to finish the critical path faster on a shorter time frame, because if you crash that critical path, the project duration will shorten. Crash the project one period at a time. Crash the least expensive activity. That's because, so in a critical path, again, you will have different activities. So crash the project one period at a time. Okay, don't crash all at the same time. Next, choose that activity which is least expensive and crash it, because you will need less resources to crash that activity. When multiple critical paths, find the sum of the crashing the least expensive activity on each critical path. Okay, so these are the techniques which are implemented to crash a project. Again, these are called heuristics, different thumb rules which are being used. So there is no mathematical optimization technique which is used, but these are some techniques which are accepted by most people, I won't say all, by most people, so that they get a fairly successful good result in crashing. Crashing activities. Now when a project is crashed, that means the time span of the project is shortened. What will happen to many of the cost associated, like the overhead cost, those will come down. So this blue line here, the expected project cost, what we see as the length of the project comes down or is shortened, and the cost comes down. But the cumulative cost of crashing, that increases when the project is shortened. The sum of these will give the total cost. The total cost, this is a convex curve on the top. The optimum point is the one at which the total cost is the minimum. So this is the optimum cost. So for project managers, they try to arrive at that point at which the total cost of the project is the minimum. But again, it's very difficult to arrive at that point. Most often they're either on the left or on the right. So the optimum point is not reached, but they try to get as close to that optimum point as possible. Project evaluation and review technique. What are the advantages of this technique? It forces the manager to organize and quantify variable information. So, for the first and foremost, the project is divided into activities. The project manager is um, has to do that before he starts the part technique or before he can implement the part technique. It provides the graphic display of the project and its major activities. Next, activities that should be, he identifies activities that should be closely watched. Now, which activities would be that? For most scenarios, it would be the critical activities which should be closely watched because if the critical activities are delayed, the whole project would be delayed. He also identifies, by he I mean the project manager, he also identifies activities that have got slack. Why is that important? So he can divert some of the resources from those slack activities to activities which are critical or on the critical path. So these are some of the advantages of this part technique. What are the sources of error in this technique? The project network may be incomplete because of not having enough information. You may not know all the activities which are related to complete the project, and also what are the relation between those activities. So that's why it said that the project network may be incomplete. Procedural relationship may not be correctly expressed. The relationship between activities may not be correctly expressed. The time estimate may be inaccurate. Whatever time you have assigned to the project or activities may not be accurate because maybe it can take much longer time than you expected. There may be tendency to focus on critical path. Again, that's not a good practice. As I said before, if all your attention goes to the critical path, non-critical activities can finally turn into critical activity, and in that case you will have number of critical path which you have to deal with, which is risky. Major risk events may not be on the critical path. Again, for the part we don't consider risk. We consider either the deterministic time or the probabilistic time, but risk can be associated with some of the activities. Unforeseen risk, which is beyond your control. So in this part, we don't consider that risk, and that might lead to a big disaster. That risk can be in a non-critical path, but finally that path not only becomes critical, but it exceeds the length of the critical path, and in that case, the whole project would be delayed. For the critical path, critical chain project, we often consider the pessimistic time, which is the longest time. Again, that may not be always to justified because most activities would be completed before that pessimistic time estimate. When activities are finished ahead of schedule, that fact may go unreported, so managers may be unaware of the resource that should potentially be used. So you have an activity which is, say, the pessimistic time was 10 days. So it actually got over in 7 days. So you have got resources for additional 3 days. So that is left, those 3 days. What the project manager can do is he can allocate those resources to some other activity. So that would be the ideal scenario. But most often the project manager overlooks that, or he doesn't have information that the project is already over. So in that case, those resources are unutilized. The critical chain is analogous to the critical path of a network. Few features of the critical chain approach is the use of various buffers like feeding project capacity. Oftentimes, project managers try to keep a buffer. They do have additional capacity, additional resources, so that any unforeseen activity or unforeseen delay can be taken care of. There are different softwares which are used to manage project. One of that is CAD. There are other devices, project management tools like MS Project, Microsoft Project. Again, uh, there is a course on project management where this software is taught. This is a very important tool, MS Project. The advantage with this tool is it helps you arrange all your activities in sequence, and it does all the estimation. Um, it has an inbuilt logic in it. Like when one activity ends, the following activity will start. It will estimate the slack, the critical path, resource allocation, and all aspects of the project are in it. And um, for a big project, it cannot be done with pen and paper and calculator and whatever. You need some of these tools to estimate a, a big project with all its complexities. What are the advantages? Again, I think we discussed it. Provides a logical planning structure. It enhances communication among team members. Uh, because this tool, the software tool, enables multiple people to work on it. So people can update it, and others, the team members, can see what's the present status. So it can be real time. Uh, can flag the the occurrence of constraint violations. So you can set up constraints, deadlines, milestones. If there is a violation, so it can be a red flag. Does it make sense? So that really doesn't look like a flag. So you can set up certain milestones on your project. And if any of the milestones are violated, that is, the work isn't accomplished within that milestone, so it might cause a red flag. So that is an indication that there is a violation, and that might go to the top management, or it can go to the project manager. So he can have control on all activities by means of those milestones. So that's a good way. So even if it is not being reported by the team members, uh, the software is automates the reporting process. There can be also what if scenarios. So if there is a change in certain activities, duration, cost, you can estimate what would be the impact of that. So there can be scenario testing, there can be sensitivity testing of both time and resource. Risk management. Risk are inherent part of the project. Again, sometimes the project manager overlook this, but this is important risk. There can be failures, there can be uh, unforeseen activities which can delay a project. So project manager has to plan for resilience into project management. So there can be delays, there can be increased cost, so there can be cost escalation, inability to meet technical specifications. So all these are part of a project. This can happen, and they do happen. And the project manager should have some standby option. So some plan, like what they should do when any of this risk happens, or any of these unforeseen activities happen, which is delaying your project or increasing the cost. So a good risk manager will identify as many risks as possible, try to understand the probability of that happening, and then they establish contingency plans. So that's resilience in the network. So contingency plan and budgets for dealing with any of those occurrences. And finally, what we see is the operation strategy. Projects present both strategic and operational risk. So it is critical to devote sufficient resources and attention to project. Projects are often employed in situations that are characterized by significant uncertainties. So because there are uncertainties, it requires more careful planning, because you don't know, its project is something new. It might be a greenfield project, so there can be so many unforeseen things happening. So the careful analysis of those situations is important, so that the project manager can have some comprehension what risk can happen, and he can be prepared accordingly, and he can have some contingency plan. Project software does help to understand some of these criticalities, understand some of the risk, and what are and try to establish some standby option. Again, everyone should understand, like, in spite of all the planning, projects do fail, or has failed and will fail in the future. But again, that should not stop project managers from planning. They should devote as much resource and time to plan as carefully as possible. So this was a quick uh, presentation on project management. So I gave you an overall understanding of what a project is, what are the different tools which are being used in project management, what are the different um, type of network technique which are being used for project management. And again, we talked about little bit on risk, um, how risk can happen, and what are the different contingency plans the project manager